Welcome, everyone, and thank you for taking the time to attend today's webinar entitled Transforming Smart Infrastructure with Lidar Intelligence. Let's get started. As you can see, we have the usual housekeeping items. Take a quick look. Please use the Q&A for questions. We'll answer those at the end of the session. We will be providing a recording to all registrants, and there will be 2 polls. My name is Gene Rowe. I'm the founder of Lidar News. I'll provide a few introductory slides on the potential impact of Lidar in this decade. Paul Rutter, Director of New Business Development at Cepton, will present his thoughts on intelligence for a smarter world. And he'll be followed by Klaus Wagner, Director of Product Management and Marketing at Septon, who will provide his insights. We then shift to Behzad Haravi, CTO at Vortex, who will discuss a case study involving a 3-month pilot using 8 buses in the Future Mobility Test bed, which is in Birmingham, UK, in collaboration with WM5G, National Express, and BT. And the final speaker will be Patrick Blattner, CEO at the Indoor Lab, who will wrap things up with a couple of recent case studies that his company has been involved with. But first, let's go to the poll questions. Question number 1. What do you think should be prioritized in building the next generation of smart infrastructure? You can select more than one. So we'll wait a couple minutes, hopefully get some feedback here. It's looking pretty evenly distributed, actually. Still getting a few more. Appreciate you taking the time to provide this feedback. So that looks like about it. A few more, okay. End the poll and share the results. So as I mentioned, it's looking pretty evenly distributed. I guess the top 2, upgrading hardware, technology and components, and stronger software capabilities, take the top slots. So we'll stop sharing that one and move to question number 2. Launch that. What do you think has prevented Lidar from being deployed at scale in smart infrastructure? Once again, you can select all that apply. We're getting a pretty good response. This one's a little tighter. And that looks like about it. So we'll end the poll, share the results. And in this case, it looks like the top one will be the cost. High cost to purchase, integrate, and maintain. So we need to get the larger scale manufacturing going to get these costs down, but I know a lot of people are working on it. Lack of technical know-how is the second one there. So We can stop the poll. Before we get into the detailed presentations, just a few introductory thoughts on the future of LiDAR and why I'm predicting that LiDAR will become more widely used than GPS by the end of the decade. As you can see here, there are several really powerful inherent reasons why LiDAR is such an important remote sensing and high capability technology. With the world population moving to cities at a staggering rate, the need for intelligently managing traffic, parking, utilities, security, health, and much more is rapidly increasing. Real-time situational awareness is the key to making more informed decisions, and LiDAR is the best technology for delivering that critical 3D visualization to make cities smarter. The same applies to industrial environments and large spaces like airports and sports venues. Why will LiDAR become more important than GPS? In 2 words, autonomous vehicles. Despite what Elon Musk is selling, LiDAR will be on all AVs because of the improved safety that it provides the vehicles by the end of the decade. The average consumer may not know what the term LiDAR refers to, but that's pretty much the same as with GPS today. Safety is the key. The AV industry needs to do a better job of, in my opinion, emphasizing the improvement in safety that LiDAR will provide. Will it completely eliminate accidents? No, but could it significantly reduce the nearly 40,000 highway deaths in the US alone each year? I believe it can. Unfortunately, the current positioning of the technology is setting the bar much too high. Suppose LiDAR could reduce the number of deaths by 50%. That would seem to be a significant improvement to me. And over time, I think it would significantly improve.
Hello, this is Paul Rutter, Director of New Business Development at Cepton Technologies, and thank you for your participation today. Cepton was founded in 2016 with the vision of supporting the automotive and smart infrastructure markets. We pursued this direction because the automotive market would provide the volume and scale that would drive down costs to support other smaller but growing markets. Cepton LiDARs use MMT technology, micromotion technology, which is proprietary and unique in the industry. All of Cepton products, long and near range, use the same base technology. Septon is now on our 4th generation of LiDAR development since the company was founded, and recently announced the auto industry's largest award to date with General Motors. We will be launching a version of our Vista X90 LiDAR on an upcoming Cadillac platform in early 2023. This will cascade into 7 or 8 additional platforms, including the pickup trucks and SUVs, over the next 1 to 2 years. The addition of LiDAR with the existing sensor suite will enable GM to upgrade from the current Super Cruise system to the Ultra Cruise system, which enables hands and foot-free driving on over 75% of US roads. And finally, Cepton has partnered with Koito, one of the largest global automotive headlamp manufacturers, to produce this product in one of their fully certified automotive plants. Next slide, please. A little bit more about MMT. MMT is a patented technology that is unique to the LiDAR industry. There are no mirrors, no friction, or spinning mechanisms. This technology was introduced with the intention of providing a reliable, cost-effective LiDAR that could be scaled up or down to enable near, long, and ultra-long range LiDAR variants to meet multiple use cases and serve multiple markets. From the sketch on the right, the laser source emitting lens and receiving lens are one unit moving together by activating the components that look like tuning forks using a magnetic voice coil. This motion is what creates our scan pattern. Next slide, please. Septon has a full range of LiDAR models, both industrial grade and automotive grade. The Vista P and Sora P models have been in production for over 2 years and are the main product currently deployed in numerous smart infrastructure locations throughout the world today. You'll hear more about these deployments from our partners in a few minutes. The Vista X series is our latest automotive grade LiDAR. As mentioned before, the Vista X90 is the model that will launch in production next year on the General Motors platforms. This is a 90-degree horizontal field of view. We are also developing a Vista X120 variant that will have a 120-degree horizontal field of view. Both of these models have a 200-meter range with very tight resolution. Our latest Vista variant is the X45 ultra long-range LiDAR with a max range of up to 300 meters. We will have A samples available soon. And finally, the Nova is our near-range LiDAR with a max range of about 30 meters. With its very small form factor, it is very easy to integrate these units into vehicles, robots, or any smart infrastructure application. Hopefully this gives you a good overview of Septon. And with that, I'll turn it over to my colleague Klaus, where he'll talk in more detail about how LiDAR is impacting the smart infrastructure space. Klaus?
Thank you, Paul.
Thank you,
Hi,
Paul.
everybody. Klaus Wagner. I'm located in Germany, and I'm looking after non-automotive markets exclusively. So I'll focus on those in the next slides. Jean, do you have my slides as well? Okay, so let me start here. The question always comes up and has been already hinted a little bit before, why LiDAR? We have cameras, we have radar, so why do we need a LiDAR on top? Well, one of the reasons is that LiDAR provides an actual 3D point cloud. Every point in the LiDAR returns as part of its data has an exact spatial dimensioning. Unlike cameras, where you have to triangulate and you get a lot of problems with difficult light conditions. We'll see that on the next slide. In addition, if you use an edge processing perception system, you can reduce the bandwidth load quite a lot. Over the network, you need to transmit the data over. So that could be used there as well. The data is fully anonymous. I just had a discussion today with a customer. So if you, especially here in Europe, it's a big concern. Surveillance and monitoring of open spaces, public spaces, people don't want to get filmed unless something is really happening and it may become necessary. But in general, for statistic analytics and so on, you don't actually need a person's face to run such kind of analytics. In addition to that, LiDAR performs well 24/7. It has its own light source, so it does not have to cope with darkness, with ideal lighting conditions, with foreground, background distinctions where cameras struggle. So all these kind of aspects are features which enable LiDAR to add to camera and LiDAR, as Jean already pointed out before, in the automotive space as well. So not as a solution for everything, but to close a security, a safety gap in addition to those other sensors. If you go on, please. Example of situations where cameras struggle, for example. You can see it's a pretty dark picture, it's a dark surrounding. The person in the back is barely visible in a camera. However, you can very clearly see them in a LiDAR point cloud. Identify them. Now you can see them because they come to the front, of course, right? So those kind of situations, LiDAR helps to provide more data, more accurate data, and enhance security and safety for that kind of situations. Okay. Next slide. In addition to the LiDAR itself, which provides raw data, quite a lot of raw data, we also offer a perception system called Helios. It consists of the LiDAR themselves, an edge processing unit of different sizes depending how large your system becomes, and our perception software stack pre-installed and pre-configured on the edge computing unit. At this point, we can classify two different object classes, vehicles in general, and persons. And we are working on the next generation of the software to add features, to add classifications, for example, bicycle riders or different types of vehicles, and also adapt the software to be used on a mobile platform like in cars. Like Paul mentioned before, there are OEMs, car OEMs, who want to do their own perception, so they only use the LiDAR and the point cloud, but there are others who want to have a pre-processed data stream, so they have a lower load on their own computing and fusion system in the vehicle. What our perception software also allows to do in terms of the features it offers is to define a so-called 3D space. So you can actually define a space in the field of view the LiDAR is looking at. And you can count, for example, how many people go in, how many people go out, how many people are in that space, how long do they stay in that space. You can generate all kinds of very interesting statistics and even build a business case, for example, for use cases in malls. Where do people go? Where do they stay and look at displays, and so on and so on. Our software also offers the feature of merging several LiDARs into one unified field of view. You can do that up to 6 LiDARs per edge processing unit, but you can also connect one edge processing unit to another, building really big systems. We had one customer building and proving, it was a proof of concept, 21 LiDARs to monitor an entire train station. And we have been dimensioning systems up to 125 LiDARs. So in that way, you can, for example, keep the ID of one person or one car, depending on what you look at, and follow that over several LiDARs over a very large area in a large space. You can see here a bit more examples on a 3D zone creation. You can even make it detect people, in this case, above a certain height. So you can put a lower height and an upper limit to this space. You can detect intrusion, a very interesting case for security applications. We'll get to that a little bit later. So you can detect whether somebody is intruding in a certain space where nobody should be. You can overlay a floor plan and kind of reflect the actual layout of the space you're looking at with the point cloud, and do the same kind of calculations in terms of people entering, going out, how many people are in there, and so on. And here a few examples of different applications in the smart cities area. We're going to talk in a bit more detail about a few of them in a second. So everything that's got to do with as Jean already mentioned, parking, analytics of people movement within cities, but also in terms of security and safety, pedestrian detection, intersection monitoring, track obstruction detection. So do you have any obstacles on a train track, on a rail track? For the smart spaces area, as I mentioned before already, footfall tracking, occupancy tracking, queue management, and even another feature of our software which it offers is to monitor social distancing, a very important aspect, at least for the last 2 years during the COVID pandemic. Security safety, as already mentioned partially, perimeter monitoring, access control, platform safety. We can also detect tailgating using our software, and all kinds of safety feature or safety applications for industrial applications. And here a bit more examples on cooperations we have ongoing right now. With Ford in Detroit, with a unit of Ford, which is looking at V2X communication, as many experts agree, and you may have heard, everybody's talking about autonomous cars and making cars autonomous. But it seems like, or some experts claim, that you need the same thing outside of the car. So you need sensors, detection, perception along the streets, communicating with the vehicles to ensure optimal safety there. AlpLab is one of our partners in Austria. They have installed several LiDARs, you see an example here, to monitor intersections and run analytics at what they call near accident situations. The goal there is to optimize the traffic flow to avoid such kind of situations, the markings on the street, the switching of lights, and so on and so on. Vortex, I'm not going to go into much detail here. Bezat on the call will explain in much detail their application. Very interesting and fascinating one. I like what these guys are doing. Bola Ponce and Barrier One are partners working in the perimeter security safety industry. And again, to assess situations of threat, to protect what are called sensitive sites, like in the case for Barrier One, to monitor kind of secure entrances to security sensitive sites, like army camps, for example. Oh, sorry, I forgot Indoor Labs here. Again, not going into much detail here because Patrick on the call will describe their use case. By the way, you'll find some of these applications also in terms of videos on our website. They're very interesting to look at. Short videos, but very educational. Bellem is one of our partners in the Nordic countries. A young company focusing on LiDAR for industrial applications. In this case, they developed a so-called smart railway crossing, which allowed ultimately to increase the throughput and the speed of the trains running over those intersections by monitoring for obstacles, people on the tracks, or whatever other items which could impact the safety and the travel of the trains. Red Fox ID is one of our main partners in a very important field in the field of tolling. We'll look at that on the next slide a little bit. We're working with them in the US and meanwhile worldwide. It's a technology which is proliferating right now, meaning our sensors in connection with Red Fox's perception, which can reconstruct out of the point cloud data, which is used by the operators for the actual tolling. Last but not least, one of our partners in South Africa, in the city of Cape Town, which is considered as a technology hub, and they're using our sensors and perception software for lane usage monitoring, analytics to improve traffic flow, restricted lane usage by vehicles which are not supposed to be there, and those kind of applications. So there's a lot of action there in this field right now. Just to point out, let me go back here, sorry. A lot of these companies, I mean, some of them are really, established companies like Ford and so on, but a lot of these companies are startups themselves, because this is a new technology. Established companies do not jump so quickly onto this kind of sensors, and new companies understand the potential and start developing new applications which still have to impose themselves and really achieve a big market. As I mentioned before, our partner Red Fox ID is working with us on tolling applications. And hold on, let me turn off this here. So one operation mode, so our LiDARs have two operation modes. One is looking at a certain area and returning a point cloud of that window to reality, like a normal camera as well. The other application, the other operation mode is to produce a line scanning kind of 3D point cloud. This, however, can be done or is done at a very high speed at 380 Hertz, meaning that a vehicle, so in this case, it's one of our current Sora P sensors, they produce 3 lines which swing, as you can see in this video, left and right, And even if the car is moving at a high speed through these 3 lines, due to the 380 Hertz frequency, it can still return a very accurate profile of the car, or a very accurate profile can be reconstructed from the point cloud, which allows the tolling operators to correctly toll the respective drivers. You can get the dimensions, you can get speed, all those kind of information. You can detect whether there's a trailer or not. All this kind of informations can be extracted. And you can see a few examples here on the left side, how dense the point cloud is from cars, bicycle riders in this case, passing through those 3 scan lines. Thank you very much. With that, back to Gene.
Okay, let's turn it over to Bazad. If you can stop sharing, Klaus.
Yep, done. Yep.
And Bazad, you can take over.
Yes, thank you. Hopefully you can hear me and see my screen.
That looks good there. I can hear you. Can other?
Okay.
Yep, we can hear him and see his screen.
Great, thank you. Thank you, Jane, for inviting me, also to all the participants for listening. I'm Behzad Ravi, CTO and co-founder of Vortex IoT, now part of Marston Holding in the UK. Today I will present our LiDAR-based technologies and case studies. To go to the next slide. Yeah, case study that we have recently carried out in the UK, in the West Midlands, Birmingham, Coventry area, if you're familiar with the UK map. CURBS, or Continuous Urban Scanner, is our technology for infrastructure and environmental scanning that can provide condition-based monitoring for urban and road infrastructure assets. It aims to maximize visibility to assets, delivering outdoor location intelligence and deriving meaningful insights from geospatial data, and here specifically LiDAR, which enables local authorities and councils in the UK for smarter decisions and enable them to migrate from reactive maintenance to more proactive and even predictive maintenance. The technology combines 3 transformative technologies, AI, 5G, and LiDAR, all into one device on the edge and cloud. The device itself can retrofit and is designed to retrofit to municipal and public transport vehicles, also any mobile platform. And it turns them to urban scanners, effectively allow them to scan the same route and the same road that they frequent every day. So on each travel, on each journey, they scan the environment and they discard the dynamic elements there, the pedestrians, the cars that are parked, looking into the background, what's happening there. And on every journey, a new point cloud is generated. So therefore, we have a point cloud on demand coming from this system. Anything that changes in this background, including here, as you see, a slow changing feature like a pothole, or it could be an obstruction or a deformed lamp column. This can create a notification in the system for the local authorities to let them know that an asset defect has been detected and classified. Over time, this creates an urban database of dynamic objects in the urban database, and we can track and create a lot of use cases from this. The use cases can be categorized into 3. The objects or features that are meant to driven over, like road marks, potholes, spillage, or even flooding. LiDAR allows us, because we can get the reflectivity of the surface. We can monitor reflectivity of road markings to see, firstly, what's the remaining area and what's the reflectivity of the surface of their visibility. For potholes, again, because of LiDAR can measure and have depth information, we can see how deep the pothole is, what the lateral extent of the pothole is, and how much material or cost will be for the local authorities to repair it. And other use cases, like median strip, to see the condition of the median strip of roads and see if is there any overgrown vegetation, or if maintenance is required. Also measure the actual curb upstand to see how much of the curb is remained there for resurfacing, or even temporary elements, so objects like roadwork signs or bollards or cones. And thirdly, the curbside assets and objects like lamp columns, road signs, if they've been vandalized or they've been deformed over time, or their, again, reflectivity of the surfaces has been compromised, it can be recorded and reported. The devices you see, it's retrofit in the back or front of a bus. We partnered with National Express, and they have the largest fleet of buses in the UK. As you can see, in West Midlands, we did the pilot, because we were funded by West Midland 5G and Department for Digital Culture and Media and Sport in the UK, carry out this project and create this technology, and also in partnership with British Telecoms, BT. As you can see the device here, we built this just last year, and the technology will be introduced as a product to the market this summer. The device is powered directly from the bus and comes with its own infrastructure of 5G modem integrated and GNSS IMU on board, as well as HD camera and 3D Lidar together in one device. And we use mostly camera for validation of and training AI models for us. The data and the point cloud that we create on every journey is integrated with a GIS, geographical information system, and also can be used for asset management system, and as mentioned, outdoor location intelligence. There are some videos of what we collected and how the device looks like. We had 3 months pilot in Birmingham with 8 buses in 3 routes to collect this data and report to us, stream the data, basically both point cloud and camera data to our servers. And here's what the actual device sees. There's a side-by-side view from the camera, onboard camera, and also the data from Lidar and the point cloud. So what happens here is this is not the raw data. This is actually processed on the edge on the device. And what we do is we concatenate the frames that are collected at different locations. So again, remember that the Lidar is now deployed on a mobile platform on a bus, and it moves. The frames are stitched together and concatenated together using our proprietary algorithms to create a dense point cloud, as you see on the left. This data, again, on each journey is transmitted via 5G to our cloud backend, where we have the semantic segmentation and AI classification there. Each object, as you see, comes with quite good resolution here, again, thanks to Cepton's technology. And there's lots of use cases we have explored in the pilot. One is detecting parking violations and detecting empty parking spots. One here is to measure the actual upstand of the curb. Or it could be the assets, road assets or street furniture, like here a bus stop that National Express were interested in. Traffic signs and their condition, their physical condition. Temporary elements like traffic cones to make sure they're there or not been displaced. And also road marks to find the remaining surface area and also retroreflectivity of it. Other examples also to show another difficulty in this technology is because GPS, GNSS is not accurate in urban areas. We rely on using Lidar itself for using SLAM and using also IMU data that we have there in high precision to be able to recreate the map and stitch the frame together without drifting on these sharp turns that you see here. The colors that you see here is actually the reflective index of each point in 3D, and we can go through this map and rotate around and see what's happening. And also, once the AI engine has processed data, here's what we see. So the points are segmented and classified as different objects on the same area that you saw the point cloud was collected. And here you can see the accuracy and crispiness of the point cloud that is generated over only one journey. And you can imagine on journeys over and over, we can improve this point cloud and get better 3D image and map of the environment for our monitoring purposes. Okay, Jean, this concludes my presentation. Thank you.
Very good. Very impressive. Thank you, Bazad. Patrick, are you there?
I am here. I am here.
Excellent.
Let's
Hand it
see.
over to you.
It says you cannot start screen share while the other participant. Okay, so let me try it now. There we go. Okay. Can you see my presentation?
Yes.
Okay, perfect. So hi, I'm Patrick Blattner. I'm the CEO and co-founder of the Indoor Lab. I want to talk a little bit today about a initiative that was at the Orlando International Airport during the height of COVID. It lasted from 2020 to 2021, which was the foray into a whole host of new things in which we're doing in multiple airports now and other theme parks as well. But this was all done using Cepton P90 Lidar sensors and their Helios perception software. And it helped us create one of the safest terminals in America that was touted by not only Orlando International Airport, but also Connect Media at the time that brought us into the airport as a partner of theirs. So I'd like to first start off by looking at the world in which we were deployed. So you can see here, this was Terminal 2 of Orlando. You've got, this was a Southwest terminal, very low ceilings, atrium effects down the center. So different times of day, you've got lighting conditions that are an issue. And one of the benefits, of course, with LiDAR and the LiDAR in which we're using, which is Septon, is horizontal field of view and the reduced infrastructure. So the points that where we deployed these LiDAR sensors are at these yellow dots. And so this is covering roughly 50,000 square feet. And you can see 1 through 7. And these are sensors that were used for multiple objectives, which I'll touch on today. So from there, when you look at a spray map across the entire space, you can see that we're covering end-to-end and wall-to-wall. So now if I run a blacklight view over it and you start to look at people moving through the environment being handed off from one sensor to another, you can see that we get a very good view of hanging on to that individual moving through the space through this vapor trail replay, if you will. And the one other point I'd like to call out here is you can see at gate 103, we had one sensor there. We were also doing real-time bathroom counts in and out of the bathroom, as well as occupancy in the bathroom live at the time in which this pilot occurred. And there was a whole host of reasons behind that, which I'll discuss. So another way to look at this, so when you look at the traffic moving kind of, this is sped up through a replay product that we had previous, you can see people getting off of gate 107. And you can see the people moving through the space. So really the point here is being able to create a mesh network that creates seamless handoffs from one object to another without dropping that object. And looking at an airport space where there are a lot of obstacles and lots of crowds of people, in order to maintain accuracy with your data and the fidelity of the data, you need to have a high dense mesh network, which we are afforded by using Septon sensors. So the other point here that I really like to drive home is the ability to track an individual journey. And this is the cleaning crew. This was one of the objectives of the test, and we were to measure the cleaning crew going in and cleaning the seats and the benches within the terminal. And so you can see the accuracy of handing one individual off as he went through all the benches. Well, this was at 3:30 in the morning. Now at this time, airports were being charged 3x cleaning costs. And what we found in many examples here is you can see now at 4:30, the cleaning crew comes back and they're cleaning again. And they're just cleaning the outside perimeter, which seems to be very efficient and effective. But now they come back, and mind you, nobody has come into the terminal yet. So they come back and they clean it again. So I, as an operator, I want to make sure that this isn't happening, and I want to educate the staff to make sure that they're aware of the areas in which they've cleaned, and so they're not over cleaning, especially if I'm being charged 3x cleaning costs at the time. So that was one of the findings that we uncovered along the way. The other initiative was social breaches. And as you can see on the left, for those of you old enough to remember Missile Command back in the day, very much what this looks like. So when people got within 6 feet of each other for more than 15 seconds, it created this explosion. Well, it's very nice visually, but how do you do something with the data? So over to the right, we created these plot maps. So the more explosions that occur, the more plots occur over on the right side. So it gives you an understanding of areas where there are problems. And from there, they can apply floor stickers at the time, put up stanchions, modify seat layouts. And it's a way in which it can be used not only from when you think in terms of an airport, but it can also be used in engagements at a retailer, or when you want to create incidents within a jail facility. We're about to install in one of the local California facility jails, and we'll have an incident plot map there where we can then detect where incidents occur and plot those where become kind of like high activity areas that they need to be paying attention to. So footprint maps, when you look at wanting to keep people apart from each other at the time, the whole goal was dispersion of traffic. And so as you look over the course of a day, you can see in the morning, the departures were front loaded in the terminal. And then during midday, you can see the departures. And at this time, you can see it's all right-sided in the terminal. So they were understaffed. So they were keeping people over on the right side of the terminal, bringing all the planes into the right side at this point in time. So you can see everything loaded over to the right at that time of day. And then, of course, at night, you can see that people come in, they basically go through the main portion of the terminal, they use the restroom, and then they go out to baggage carousel. So it really gives a good depiction kind of the anatomy over the course of a day of a terminal, if you will. So this was all on the heels of a bigger program, and the bigger program was driven by Connect Media, and Connect Media created these social lights, and these lights, which were called even flow, they were at each gate, and you can see the color of them there sitting to the left of the heat map over on the right side that's animating. And as more people entered the area or the gate, we were feeding those lights with traffic occupancy levels. And as it hit certain thresholds, it got darker and darker, closer to red. The message in the terminal was go to the lighter colors. Well, after they did post analysis on the overall program, they saw that the dispersion rates were roughly 10 to 15%. And so I don't know what good looks like, but that was a pretty high number compared to what we thought. So by having visual displays driven by data from Lidar, we were able to disperse traffic and keep families safe or safer that were coming back from Disney World, if you will, or flying out as well. So one of the last things I want to bring up, just because there's a story behind this. So Qualcomm is a partner of ours for smart city and smart venues. And this applies to not only this kitchen environment in which we're installed in at Qualcomm, we're also installed in their chip factory and doing some kind of testing there. But the point of this is, if you look at on the left side, the actual behavior of people going through a space, on the right side, you can see where those people trafficked. And if you're looking at this as being Best Buy or a retailer, where it's all about conversion and price per square foot, you can start to take information like this and really help them understand utilization through what we call a footprint heat map. And so now what that looks like is that whole area to the right can be translated to information. And here you can see on the left side of this grid, it says location, digital checkout, pizza and grill, Shuts Corner. But you can see over the course of the day that 71% of the traffic engaged with 27% of the cafe. Well, that easily translates to any open space in which you're trying to measure. And using Cepton's Lidar sensors and the dense mesh network in which we get from those sensors, we have continuously used those in some of our installations. We're currently in a theme park on the East Coast. We're multiple airports now. And as I'd mentioned, moving into a jail facility. So it really is cross-functional. And most recently, we just went live last night at, we're tracking vehicles, buses, et cetera. So to be able to leverage a capability, especially we came out of the airport space for many years using stack technology of Bluetooth and cameras and infrared as well, to now be able to have one technology, one provider that we're leveraging today that allows us to do indoor and outdoor at airports or other facilities in which we are leveraging, makes our life a lot easier because we're not having to create tech stacks and cable drops, et cetera. So this is the case study in which I wanted to present in some of the analytics. We have a whole host more if someone wants to learn more about the things that we are doing, but this is what I wanted to share with you today and how we're leveraging Septon. And I'll turn it back over to you for any open questions.
Excellent, Patrick. Definite look into the future.
Would you like me to stop sharing, Gene?
Yes,
or
please.
Okay, let me do that. There we go.
Okay, and I'm going to see if I can get to my end slides here quickly, given the time. Nope, that's the wrong one. So stop sharing PowerPoint. Yeah, it's not able to get to the question and answers. So I apologize for the problems that we were having today. We're pretty much at the end of the 1 hour session. We have time for maybe one question. I'm going to ask Bazad, how do you think Edge AI will be transformative in LiDAR-based smart city use cases?
Sure. So LiDAR data and point cloud is quite heavy in size. We in our application, basically we saw the raw data for transmission or processing, and it's quite heavy on processing as well. But for data transmission to the cloud, it requires quite a good bandwidth. That's why we use 5G. So Edge actually can reduce that amount of data while increasing the value of it using any edge processing, including Edge AI or data fusion. In our case, we use the concatenation of the raw frames of data, LiDAR data, to create that dense point cloud before it's transmitted, and that kind of reduces the amount of data and the need for the backhaul traffic to our cloud quite significantly. Yep.
Thank you, Bazad. Patrick, if you're still there, we might have time for one other How does LiDAR reduce the infrastructure needs for large installations compared to cameras?
It's one of the bigger questions we get. Historically, now that we have got multiple deployments out there and we've used cameras in the past, we have seen roughly a 60 to 70% reduction in what we would have to deploy from a camera perspective versus LiDAR. And as those of you worked in the airport space, cabling costs, depending on which airport you're in, can be quite high. And so we always wanted to remove barriers to entry, and one of them happens to be the vast amount of cabling that it took. And by being able to cover roughly, in the case in which we showed with Orlando, 50,000 square feet, with only 7 LiDAR sensors and having roughly a 97-98% accuracy of being able to hand off from sensor to sensor, that is a dramatic shift compared to how many cameras it would have taken to cover those low ceilings. And we have another installation that's happening next month at another large airport where the cameras that would have been deployed in the space, we're going to be a little bit over 40, and we're putting 17 LiDAR sensors in that case. So in every case, we're seeing at least a 50% reduction in the need for LiDAR and cabling compared to a camera solution. So a great improvement. Yeah.
Yeah, that's a tremendous improvement. We're at the 1 hour time limit. If anyone would like to stay, we're going to address a couple other questions. But if not, we thank you and once again apologize for the problems with the audio at the beginning here. This might be for Paul or Klaus. It seems in some applications, LiDARs can replace cameras, as Patrick just explained. And in some applications, LiDARs will work alongside cameras. What are the key factors that contribute to this difference?
Well, you want to take that one?
Yeah. So let me go with that. In terms of why LiDAR and not camera, as I mentioned before, one of the big points is privacy. And since LiDAR are coming down in cost, that's a different discussion, but it will come down in cost dramatically over the next years. It's a very good alternative. Working alongside cameras, it helps to provide that additional in OEMs, in cars, which is not exactly my area, but in cars, it helps close that gap where the camera does not record correctly. If you look at some of the, and I'm not trying to bash, not doing any bashing here, so don't get me wrong, but if you look at some of the accidents Tesla had, you'd know a LiDAR would have told you there is an object, brake now. And cameras do have problems in certain light circumstances. Another topic considering privacy, in some security applications, LiDARs are being used to monitor people traffic. And if they enter a certain area, let's say, or if a person enters a certain area, at that time, a camera gets pointed there, not before. So everything before is privacy secured. But if somebody enters a certain security relevant area and you need to know who that person is to be sure that it can go there in that area, then you only turn on cameras. So they work very well together, actually.
Thank you, Klaus. Patrick, Bazad, I should say, this might be for you. Are the AI pattern recognition algorithm libraries built into the LiDAR sensor, or do we have to program them ourselves?
So in our case, for urban assets, no, only for human shapes and I think vehicle shapes, Septon or Klaus can answer that. Actually, that there is a AI classification there, but for anything else, and also for LiDAR point clouds from a mobile platform, no, it needs to be programmed to it basically ourselves.
Okay, and this might be the last one. What kind of persistence strategy is being used with the point clouds? Anyone?
What does that mean?
Yes.
Yeah, that's on the Q&A, so I'm not quite clear myself on that. We could shift to one other that I have. Lidar's application in tolling is interesting. It seems Lidars are installed on the gantry. How does that compare to the existing ground-based systems?
Yeah, that's fine. I'll take that. So ground-based systems have been very popular and very widely used in the last years. However, they require quite a lot of work. You need to close lanes, you need to dig, you need to put something into the pavement. If something happens to it, you need, again, to close lanes, dig it out, and so on. So the beauty of Lidar is you put it on a gantry, it's very easy to maintain, it's easy to exchange if they break down. If something happens, if you have a failure, they can be built in a way that you have redundancy in the way they are positioned. So even if one fails, you still have coverage. So the operator does not have a loss of revenue. So there are a lot of arguments for LiDARs, for using LiDARs for tolling.
And we actually just went live at a toll last night, so it's kind of an ironic. And we are measuring at one of the biggest arteries in one of the largest states in the country, a 18-lane toll. And wow. we are measuring, it backs up on Thursdays and Fridays, roughly an hour at times. And just this morning, we were looking at the perception software for the first time, and the amount of backups, and they go through RFID readers in this case. And so we're even seeing within 15 minutes that certain RFID readers are not picking up the tags on the cars because you have to pull into the slot. It reads it, it opens the gateway, and you go out. So in the case in which we just deployed, we're seeing out roughly 500 plus feet in front of the toll plaza. From there, we can see lane changes that are happening, backups. When the car backs up, that means the 5 or 6 cars behind him have to back up. And when you're dealing with a major artery, think of it like the 405 in Los Angeles. It creates a lot of angst and a lot of angry customers. So what we are doing is helping them understand where the problem lanes are and how to solve some of this. And some of it goes way back to where you're entering the toll and people are getting pushed to one side of the toll versus having to be on the left side because of speeders. And some of that has to do with signage. So there's a whole host of things in which Cepton's LiDAR sensors are being leveraged for. And this is just another one which we're at the forefront of our learnings, but it's certainly proving within 15 minutes of looking at cars going through, we're going to be able to uncover a whole host of ways in which they'll be able to improve throughput for the entire city.
Very impressive, Patrick. I did get a clarification on the earlier persistence question. Let's see, are the point clouds stored in something like a AWS S3 bucket, then data separately in a database, or are they integrated?
That's quite specific. Yes, it is this AWS S3, and well, we were getting a little bit getting into technical part, but I think the persistent part was for like a mapping persistent or topological persistence that views algorithms there, like Postgraph and SLAM to do that, because well, GNS is not accurate enough, of course. Hopefully it answers the question. Yeah, there's lots of research also on it as well, and a lot of improvement recently on mapping persistence as well.
Excellent. Thank you everyone for hanging in there over the hour time frame, and we will connect with you in the future. Thank you.
Thank you. Thanks everybody.
Thanks, Gene.
Thank you all.